So let's go to our scripts. So we created the frame rate manager. Let's double click that. Let's understand coding a little bit from this script right here. So basically this is a function, what you see here. You have void with 2 parentheses at the end of your name, so you can actually name a function whatever you want. I can say void shut up, right? And add those 2 parentheses there, and it'll just structure it this way. So basically I can call this code whenever I want, and I can tell it to do things in here, right? And then by calling this function, it will call all of the code inside of these 2 parentheses. So the start function will call at the very beginning of your game. There is one function that is called before this, and it's void awake, right? So if I come down here, I write void awake, right? And Visual Studio will create the structure for you right away as soon as you basically finish these parentheses here. Just something to keep in mind. So this one right here is the only function in your code that's going to be called before start. Okay, so start is okay. It's just like a second basically into the loading. It'll call this code. So what this is doing, obviously I mentioned before, is just changing our maximum frame rate to 60 instead of unlimited. So these things here, anytime you write a little, anytime you add 2 backslashes, you can type whatever you want. And all this is a little note to say, obviously, in a blank code, they just give you a heads up that update is called once per frame, and start is called at the beginning of your game. So I'm going to delete this awake function. I don't need that. You don't need any empty functions in your game. None. So this script in particular is only going to do this. Only going to do that. And we're going to change this a tiny bit so that we can change our frame rate a little bit easier. So update is called once per frame. Now think about that. If you have 60 FPS, this code right here is going to be called 60 times a second. So you need to be really careful what you put in update here. There's a few different types of updates, and we'll get into that later, but you need to be really careful what you put here. It needs to make sense. Like you can't instantiate game objects here. It's just going to do it 60 times in a second, and everything's going to crash and freak out, right? So just be careful of that. So I'm just going to delete this note, because it is just a note, and I'm well aware that this is called every frame. Right here at the top, above your functions, or wherever you want, but it's better to state things before you mention them anywhere else, right? So basically up here we can place our parameters. So if I want an integer that I can change and just call this that integer, I can come up here and say int, okay? That's the abbreviated code for integer. Saw that in the animator. We'll name this frame rate, okay? And we'll say, give it a default value of 60. Okay, so you saw it say private void awake when I created that awake function, right? Private void awake. Private, basically just means it's only called from this code. You can't call it from anywhere else. So if you don't type private, it's the same thing. If there's no private before void here, or before any of my parameters, they're only within this code. I can't change anything about them. I can't see them in my inspector. So to change that from private, you change it to public, right? So a public parameter, you will see in your inspector when you select the game object with this code attached to it. And there's a few cool things you can do, like you can add little slider bars, checkboxes, right, to say if something's true or false. This right here is just going to give us a number that we choose. I can type in the number in the inspector and change the frame rate. So what we need to do now is, instead of saying 60 right here, we say frame rate. Okay, and that's going to plug in whatever this is at the start of our game. Whatever this is that I change in the inspector, that's what it'll set it to. Okay, so we can create our own function. So say I change this update to change frame rate. Change frame rate. I can call this code right here, Control C, Control V, paste that, and just get rid of that. Okay, and here I can say change frame rate. Right at the start of my game, I want to do this, right? So it's going to call this function, which is just this right here, anything in between these parentheses. So there's different statements you can make within a function that look like a function, but they're not a function. If I say if frame rate is greater than 60, I can put these parentheses in here. And this is not a function, this is an if statement. There's for each statements, there's a lot of different kinds. But basically you can structure what I want to do if this is true. Right? So if this is the case, I can call the code in these parentheses, right? So if I have this right here, whoops. if I had this below, it would call this anyway, right? Code is called from top to bottom. But it wouldn't care. It wouldn't care what this did. It would still just call this right here. So what I want to do is say frame rate equals 60. And when I do that right here, if the frame rate is above, sorry, if it's less than 60, it'll change to 60 is greater than. Sorry, I got the character mixed up there. So if frame rate is greater than 60, we want to change the frame rate to 60. Maybe you don't want to do that, but I'm just trying to explain some stuff that we can do. So that'll fix that. And just make sure it's, you know, in case you have a typo, it'll just make sure it doesn't go past 60. So now if I change this to public void change frame rate, I can call this from other codes. I can call this from UI buttons, like buttons in your game that you can click. Can call this from that as long as this is public. Right, so just as you can create a public variable or parameter, you can make a function public and call it from elsewhere as well. So you won't like see this in your inspector or anything, but because it's a public function, it can be called on another script. Okay, save. And this is a little bit better than what we had before. So my absolute maximum frame rate is it's never going to go beyond 60 because of this code right here. Okay, and here we go. Now if we check our game manager here, it's also important to note that your manager should be at a 000 position. Save space wherever you can, basically. So if you have an integer here, if this was 1, this will actually load faster than if it was 0 point a bunch of stuff. It will actually load faster. It's a tiny fraction of space regarding things like that. But if you can save it, right? If you have 20 managers here, that tiny little amount of space becomes a little bit more than a tiny bit of amount of space, right? So it all depends on how big your game is, but it's good to save that stuff where it is. So here you can see now our frame rate is right here, and we can just type whatever we want this to be. If I type 600, one more thing I wanted to show you before we click play here is in scene and game. Let's click stats. Okay, so this is going to give you some cool information here. It's going to give you the visible skin meshes, which is basically animated mesh renderers. It's going to give you your total tries and vertices. Right now, I was going to wait till I click play. It's also going to give you your FPS, so obviously nothing's going on right now. It's not playing, so it's not going to be anything very much. So because I have that maximum frame rate set, even though I have a typo here and an extra 0, okay, so it's going to stay around 60 FPS. Perfect, so we can understand that. So if I change this now at runtime, nothing's going to happen because I only call that code at the start. I only call this right at the start. Okay, so it's only going to do that at the very beginning when you click play. So if I change this to 30 now, and I click play, you can see my max FPS is going to be around 30 and stay around there. Okay, so you can actually control an insane amount about your game. You can control a lot about the engine. You can control things about the player's computer, like their RAM and their graphics and stuff like that. And basically that's how a lot of high-end games initially give you your default settings. They'll check your computer. Okay, so let's drag this game manager up to the top here, just to be at the top of the hierarchy. So when the scene loads, it loads from top to bottom. We have our frame rate happening right away there. Cool. So I'm going to uncheck stats, but anytime you want to check all this stuff, so here we have 134.4k tries. Obviously that's not true, but it kind of is. Mainly because casting shadows requires triangles as well, and that's going to double that amount, right? And depending on how many lights you have in your scene, that's actually going to increase exponentially as well. So just this is not exactly the triangles on your meshes. It's not that. It's a lot more to it than that. So just bear that in mind. Don't be like, what the hell's going on? There's a lot more going on for this triangle count right here, rather than just your models. All right, back to scene. Okay, so in my scripting folder, you'll notice I have an extra code here. We're going to create the coin pickup and the crate break very soon, probably in the next episode, but this one right here, the player controller. Scripts can be huge. Scripts don't have a cap on how many lines can be written here. You can see this ends on 23, or 22 technically, but there's no cap here. This can be 100,000 depending on what you need to have happen, right? Just mentioning that. Now, if I come over to my player controller, this is not big. It might look big if you're a beginner, but this is not a big code. So I want to mention first of all, before you guys copy this down, is that I got this from Sebastian, Lague, Brackeys, Jason Weimann, Jimmy Vegas. Those are some great online teachers. I highly recommend you find their channels on YouTube. Basically, they're the guys who taught me how to code. And Darrin, Lile, Andrew Price are some guys who taught me Blender. So just a big shout out to those guys right there. This is a derivative, basically, of Sebastian, Lague, and Brackeys. One of their tutorials. I believe it was the RPG, and Sebastian did a little bit of a spin-off with a third-person controller, because they were doing an RPG with like a click a point and click movement. But yeah, so I'm just gonna basically leave this up here for a sec. You guys copy this down exactly the way it is, Okay, and just copy everything down here. You can make the notes, especially on the animator section here. We need to add a few things to our animator, like falling, landing, jumping, stuff like that. So make sure that these are noted out until we finish that part. Right, just 2 forward slashes. So just pause the video and make sure you copy all of this down. Don't worry about understanding it. I mean, a lot of this is pretty insane mathematician stuff. And make sure you copy all of this down, pause the video where you need to, get it exactly the same. Come into your scene afterwards, after you save it, let it compile. Go to your player here and just drag the script right onto here. You can also, as mentioned before, say add component, player, controller. Okay, boom. And here you have a bunch of cool parameters here: walk speed, run speed, jump speed. And now for anyone, really quickly I want to mention, for anyone just using walk and they don't want to use run, just go into your code. Okay, and there's a very simple thing right here that I've created. So you can just delete the note section and make this run speed equals walk speed. And basically that won't change anything about your movement speed, whether you're holding shift down or not, right? So right here, running equals input.getKey, key code. So this is only keyboard keys. But we can check out the input manager in a future episode, and we'll see how we can set up a controller on top of our keyboard, maybe as a secondary or as a primary, whatever you want. Okay, so we'll figure that out. So just note that out. If you do not have a run, just make sure this is here not noted out with 2 forward slashes, right? So I do have a run, so I'm just going to leave this out like that. Matter of fact, if you do have a run and you definitely want to use it and you don't want to go back on that decision, just delete this line. Okay, so with that, basically he's ready to move around, but we need one more component. So let's add a character controller. Okay, it's a Unity specific kind of pre-setup collider with a little bit of physics. So it's got a slope limit. This is your collider here, the center, radius, and height. So we want to change this probably to, I think I just have my test here, so I'm just going to check this out. Worked out was 1.45 height, 0.3 radius, 0.8 center. So let's do that. All right, so yeah, get that, make that happen. You can see he's got a collider here, so this is basically going to plop him on the ground. Now for me, the skin here, skin width, is going to be from this point here to the floor. Your slope limit is how high of an angle he can walk up. So if the angle is higher than 45 degrees, he won't be able to walk up it. It'll act like it's a straight up wall. And the skin width, that's really all you need to worry about. This min move distance and step offset is going to be sort of a technicality for you. Really depends on what you're doing, whether you need those or not. Okay, and just quickly, we need to set up our camera first, so we'll do that in the next episode. But if you click play, you should be able to run around, right? And obviously we don't have, you can jump, but we don't have any parameters set up for those animations yet. So we'll do that in the next episode as well. All right, I hope this episode made sense. Coding is not my strong suit, but I can do a lot with it. So I hope I got some people started in understanding that. So in the next episode, we'll actually get our camera set up using Cinemachine. It's a fantastic asset. Yeah, thanks for watching, guys. Hope to see you in the next one. Bye.